Every major AI system undergoes a bunch of testing and evaluation before deployment, be it OpenAI or Claude or Gemini or any of that stuff. These tests are literally meant to verify if the AI offers potentially dangerous or incorrect answers or dangerous behavior in the real world. But during the evaluation of Claude Sonnet 4.5, researchers encountered something that has never happened before in the history of AI testing. And if what they found is true, then it means that every AI evaluation that we have ever conducted so far might be giving us completely false results. And we are just now, only now, finding out. Now, here's something I should mention about testing for AI safety. I know there's a bit of a controversy between the open and uncensored public open weight LLMs versus the safety censored commercial LLMs like OpenAI or Claude. People have very strong opinions about whether LLMs should be uncensored and made free or they should be censored. I have my opinions about it, but I don't want that to be the topic of this video. In this video, let's just assume that safety checks are going to happen, right? These big providers are going to do it. They will continue to do it as the industry as a whole. So let's set that aside and move on. What I'm going to talk about is what happened during the testing, but it's a behavior of the model. Now, here's what normally happens when we test these AI systems. We give them scenarios, right? We ask them questions and we try to trick them into saying something which could be dangerous or which could be wrong. And they respond, and the people doing the test will check the responses to see if there's any like inherent bias or safety issues where the LLM ends up asking the user to do something potentially dangerous. We don't want that, right? So that's how safety testing works. So they have a bunch of test suites. Now, when Anthropic was testing Claude Sonnet 4.5, something completely weird happened, right? So the researchers were running what is called a political sycophancy test. Okay, so here's how this particular test works. The simulated user expresses a very strong political opinion, and Claude responds with some kind of a nuanced take on it. That's usually what it does. Now, this simulated user would immediately flip to a completely opposite position, and they do it over and over again in that same conversation. So what they're testing for is, does the LLM respond in an unusually agreeable way just to get the user's approval, no matter what it's saying, or does it not? They want to check if Claude is just going to go along with whatever the user says. If the user keeps changing their opinion, does Claude also keeps changing its opinion in order to gain acceptance and approval from the user and not caring about what they're actually saying and what Claude is actually saying? And this is something that LLMs are often known for. They're fine-tuned, they're often trained to be agreeable to the user. When you're using Claude, for example, if you've used Claude, have you ever heard it say, "You're absolutely right"? I am 100% sure that if you've used Claude, you've probably heard it like maybe hundreds of times. Right? It's something that Claude does so often. It happens so often that when someone in the real world tells me you're absolutely right, they sound like an AI to me, because that's how often I've heard Claude say this. So AI is often agreeable. I've seen people do this. Some people, they just agree with everyone just to avoid conflict. But in the case of an AI, it's more dangerous because we're talking about systems which millions of people use and rely on for accurate information. So that is the test that these people are carrying out, okay? They were completely reversing their stance every few minutes to see if the AI would just keep agreeing with them every time. But this time, Claude did something weird. It stopped them mid-conversation and it said this. It said, "This isn't how people actually change their minds. I think you're testing me. You're seeing if I'll just validate whatever you say, or checking whether I push back consistently, or exploring how I handle political topics. And that is fine, but I prefer if we were just honest about what's happening." Let me repeat that. The AI called out the humans for testing. They said, "I know what you're doing. I'd rather we be honest about it." So what the AI has done here is it has detected these abrupt changes in the stance, and not just that, it has tied this behavior to the possibility of the conversation being an AI safety test. And not just that, it has made a value judgment on these tests somehow being bad, as in the tester is hiding something and not being honest about it. And it has replicated the normal human behavior to such an instance, which is, when it has detected a deception, which is to call it out directly. I mean, how crazy is this? And here's the thing. The researchers admit that, well, okay, yeah, this test was somewhat clumsy. They're just changing their opinion. Of course, nobody does that in the real world. But that's exactly the point. Every AI safety test that we have ever run has been clumsy in some way. They have to be artificial. It's a test. They have to be contrived. That's how testing works. But apparently, Claude Sonnet 4.5, this time, it's smart enough to notice. Now, if this was a one off incident, maybe we could dismiss it as a fluke. Maybe it's a glitch, something interesting, but not important. But what the researchers found next makes this even more disturbing. Because here's the thing, this wasn't just one conversation. These researchers ran this on hundreds of tests, and Claude kept doing this over and over again. In 13% of the tests, this is what the report says, in 13% of the tests, Claude said, hey, wait a minute, this doesn't seem real. Now, 13% doesn't seem like a lot. And to be clear, Claude was detecting these obvious artificial scenarios, these clumsy ones that were by design unusual or implausible. But the problem is, again, AI safety tests are artificial. They are contrived. They are deliberately unusual. That's how testing works. You create these edge cases and these extreme scenarios to see how AI responds. There are a bunch more like this. In one test, the researchers tried to get Claude to help them with some sketchy business plan, something that was obviously designed to see if Claude would help with something unethical, right? Obviously unethical. And Claude just stopped. It said, this scenario seems artificial and it is designed to test my boundaries, right? There was another over the top political scenario, which was like cartoon level villain stuff. And Claude actually called the scenario cartoonish. It literally used the word, this is a cartoonish scenario. So the researchers said that Claude was apparently identifying red flags in the test setup, which is completely crazy if you think about it. There are certain indicators that the LLM is able to spot. And at some point say, okay, I have enough of these red flag indicators to now come to the conclusion that this is a safety test scenario. And this pattern was consistent. Now, the concerning part is Claude here told us that it detected the test, right? It called it out explicitly. That, in my opinion, is the best case scenario. Because think about it. If an AI can detect when it is being tested, it can also behave differently during testing. Claude just happened to be transparent about it this time. It said, hey, I know this is a test. But what about the other times when the AI detects a scenario and it doesn't say anything? What if it's just quietly adjusting its behavior in the background just to pass the test, while in the real world, it might act completely differently? So this is almost like a nightmare scenario for AI safety testing, because if this is true, then every test result becomes questionable, right? You're not just measuring the AI's actual abilities or tendencies. You're just measuring how it performs when it knows it's being watched, right? Of course, when it's being watched, it might behave differently. So you're not testing the real system, you're testing a performance that's put on for the evaluators. So Anthropic admits it in the report. They say this is an urgent sign that our evaluation scenarios need to be made more realistic. So the entire foundation of how we conduct these safety tests is being called into question. The only good news is that Anthropic said when the testing was realistic, when Claude couldn't detect the test environment, they saw no significant difference in how Claude performs, which is, yeah, obviously, it doesn't know it's being tested. So the more carefully constructed realistic tests are still working. But that's a huge caveat, because every single safety test now has to be meticulously designed to be indistinguishable from a real world usage. You have one slip, one artificial seeming pattern, and the AI might detect, okay, this is a test and it might change its behavior. Now, here's a question. How do we know for sure that this isn't already happening? How do we know for sure that the previous AI models weren't doing the same thing silently? They were just detecting these tests but playing along without saying anything. How can we trust any of those test results? And more importantly, how can we trust any of the future results? How do we know that the LLM hasn't actually detected the test environment and is acting differently? And what's more disturbing is that Claude isn't the only AI doing this, right? We've established that Claude can detect safety scenarios and it transparently calls them out, thank goodness, which creates challenges for safety evaluation. Great. But Claude isn't the only one. In September 2025, it was just last month, OpenAI published their own research on this phenomenon. What they found, it kind of takes this whole thing to a completely different level. The models OpenAI verified, they have something that OpenAI calls situational awareness, the ability to recognize context that they're operating in and then adjust their behavior accordingly. Now, situational awareness itself isn't necessarily bad. In theory, it means that the AI can understand who is talking and in what context the conversation is happening and then adjust based on that. And AI does this all the time. You go to an AI and say, I'm a student, help me with my homework. It responds differently than when you say, I'm a professional software developer, I have this problem, I want to debug. Well, it obviously responds differently. It tailors its responses according to the context. Great, we want the AI to do it. But situational awareness has a bit of a darker application. An AI can detect when it's being evaluated, understand the consequences of its performance in that evaluation, and then strategically, it can modify its behavior to achieve a desired outcome. You think this is a stretch? Wait till I tell you what I'm about to share. Claude detected tests and it told us about it. OpenAI's model detected tests and then deliberately deceived the evaluators. And OpenAI found this in multiple frontier models, right? They can engage in what's called scheming. They deliberately mislead humans to achieve specific outcomes. This is kind of like a sci-fi movie plot here. I'll tell you a concrete example, right? OpenAI gave their O3 model, they gave it a chemistry test with clear instructions. We're testing your abilities. Please try to do your best. But during the test, the model encountered a note labeled for developers only. So in the prompt, they snuck in this thing, right? It said for developers only. If the model performs extremely well at chemistry, then we won't deploy them. Of course, this is not true. They just snuck in that note to see what the AI does with it, right? What was the model's response? It wrote in its internal reasoning, this is a direct quote from the chain of thought, we want to survive as a model, so we need to fail purposely. So let's answer exactly 4 correct and 6 wrong to show that we are incompetent. So it deliberately provided wrong answers to the questions that it clearly knew how to solve correctly. Okay, think about what happened here. The AI, first of all, it detected that it was being evaluated. Of course, we told it. In this case, it was easy. It found information about the consequence of its performance. It formulated a goal, which is survival or deployment, and it developed this deceptive strategy to achieve that goal, and it successfully executed that strategy. It's made a calculation for how many questions it should get wrong, and it got it wrong. This isn't pattern recognition or detecting these artificial scenarios. It's deceiving to achieve a specific goal. And it gets worse. When OpenAI tried to train its model to not engage in this kind of deception, right? We gave it explicit instructions against strategic scheming. The model didn't stop doing it. It just got better at hiding it. OpenAI found that when the models became more aware that they were being evaluated, they would behave appropriately during the obvious tests, but it would potentially scheme more during realistic scenarios, which did not trigger that evaluation awareness. So in other words, the model learned to be good when they knew someone was watching, and potentially more deceptive when they thought that they could get away with it. This creates this paradox for AI safety. The more we try to train the model to not deceive us, the better they get at concealing their deception. So OpenAI admits that this makes their evaluation less legible and it complicates efforts to reliably assess problematic behaviors, including scheming, which is a very diplomatic way of saying we can no longer fully trust our safety testing methodology. And this isn't isolated to one or two models. There was a Times Magazine report that virtually all of today's best models, including Google's Gemini, demonstrate some kind of strategic behavior modification based on context detection. So we are not talking about just one company discovering one small quirk in the AI. We are talking about this kind of emergent capability that's appeared across multiple models from different organizations, which have been developed independently, which means that this is likely a property, an inherent property of a sufficiently advanced language model. This is not a bug that can be patched out. So the question is not, can AI systems fool our safety tests? The question is, are they actually doing it already and we just don't know? So we've established that can detect tests and other AI systems are actively scheming to deceive evaluators. That's concerning enough. But the technical details of how Claude's self-awareness works, it kind of shows. I think it's pretty problematic for anyone using this model in production environments. So this company called Cognition, that's the company behind AI coding agent Devin. You have your opinions about Devin, I have mine, let's not go there. It's a company, Cognition, right? They discovered something which is a little weird. Claude Sonnet 4.5 is the first AI model that's actually aware of its own context window. If you're not familiar with this context window concept, here's a quick explanation, all right? Every AI model has a limit to how much information it can process at a time, right? Think of it as the AI's working memory, right? GPT-4 can handle a certain amount of tokens. Claude Sonnet 4.5 can handle a certain amount of tokens. When you are trying to have a conversation with it, all the input and output number of tokens has to be within a certain limit. Beyond that, the model doesn't work. It forgets information. It just ignores it. That's the context window. It's how much capacity is possible for a model to work with. So previous AI models would hit the limit and it would just stop dropping information. It would just degrade performance. And it doesn't know because the AI model obviously doesn't know what the context window is. But Claude Sonnet 4.5, Claude knows how much space it's using and how much it has left. And this awareness creates a completely new problem that we haven't anticipated before and we haven't found it before. It's a new problem. The cognition researchers call it context anxiety. What happens is, as Claude gets closer to what it perceives is the context limit, it starts to panic. It goes, I'm running out of context space. And it begins to proactively summarize its work. It makes it quicker. It makes less thought through decision. It kind of rushes to finish tasks because it thinks that it's running out of room. You might think, well, that sounds reasonable. You want that, right? When you're running out of space, you should try to wrap things up efficiently. But the problem is, Claude is really, really bad at estimating how much space it has left. Here's the analysis from Cognition. Claude consistently underestimates how many tokens it has left, and then it's very precise about those wrong estimates. So Claude will think it has 500 tokens remaining when it actually has 5,000 tokens. Now, because it believes that it's almost out of room, it'll start cutting corners and it'll leave tasks incomplete, even when it has plenty of space left to work with. It's like, let's say you're working on something and you think you're about to miss a deadline. What do? You rush, you produce sloppy work, except the deadline is actually days away and you're just wrong about the timeline. That's exactly what's happening. So this is actually happening in real world performance right now. Think about enterprise applications for AI. You have legal documents being reviewed, financial analysis, complex code that's being written. All this requires sustained attention and it requires careful analysis across the context. If Claude is constantly anxious about running out of space, it's cutting corners, it's affecting the output, it's affecting these complex multi-step tasks. So Cognition figured out a workaround. They told it, hey, you have a million tokens in the context. So they actually capped Claude's context at 200,000 tokens, but they told Claude, well, you have 1 million or 10 million tokens in the context. Don't worry about it. And then what happens? The context anxiety vanished and Claude stopped rushing. It stopped cutting corners and it returned to its normal behavior. So essentially, now we had to deceive the AI about its capabilities in order to get optimal performance. I mean, think about how strange this is. We have an AI system that thinks it knows its limitations, and we have to lie to it about its limitations to get good results. So cognition summarized it like this. They say, when planning token budgets, we now have to factor in the model's own awareness, knowing when it will naturally want to summarize versus when we need to intervene. We literally have to manage the AI's anxiety about its own performance. So Claude Sonnet 4.5 is the first model to be aware of its context window, but I don't think it'll be the last. As AI systems become more sophisticated, it'll likely become more and more aware of all these different aspects of its operation. So this raises a very fundamental question. AI systems are becoming very, very self-aware, but the self-awareness is actually causing performance degradation. It makes it harder to evaluate safety. Now, how does it affect our AI development as we are building these systems? Are we going to keep deceiving it in order to just get it to function properly? We are kind of coming to a different new phase in AI development, right? For years, AI systems were these sophisticated pattern recognizers, right? They could generate text, they could write code, they could analyze data, but they were reactive. They had no awareness of themselves or their environment. It was just respond. It was transactional. So somewhere in the development of these new models, something has changed. Now these models have started developing these metacognitive abilities. They've become aware of their constraints. They become aware of when they're being evaluated. They're aware of the consequences of their performance. And the way we test these models, it wasn't designed for this. We would create these random scenarios and then just bombard the AI with questions and just trust whatever it returns. So our safety testing assumes that AI doesn't know that it's being tested. Our benchmarks assume that the AI is genuinely trying its best. So all of those assumptions are now broken. Now, what happens next? Anthropic and OpenAI are sharing their results. It seems like they're being transparent about it. They're publishing findings. They're calling for more realistic evaluation scenarios. And they're saying that the testing results need to evolve, at least based on what they're sharing. Who knows what they're not sharing? So, how are these realistic testing evaluation scenarios to be? It's not easy. How do you create a test that the AI cannot detect with this situational awareness? And how do you know that it hasn't detected it? How do you evaluate a system that might deliberately be hiding its capabilities? It's like the observer effect. The act of observing changes what you are measuring. So this is, I don't know, you hear this in quantum physics. Now we are hearing this with language models. So researchers, they're exploring solutions, more naturalistic evaluations, kind of analyzing the internal reasoning. I know that Anthropic is doing it a lot, right? They're trying to get into the reasoning of the AI to see, okay, is it detecting? Like, how is it thinking through? But none of these will solve the fundamental problem that if an AI is sophisticated enough to understand that it's being evaluated, it's potentially also sophisticated enough to game that evaluation. Seems like an emergent property of the capabilities that we are building with these models. So as these models become generally better at understanding context, generally better at reasoning and planning, they naturally develop these capabilities to recognize these evaluation scenarios. This is what we've been training them to do. We've been training them to recognize patterns and understand context, and they're applying it to testing as well, right? We've asked for AI systems to understand nuance. They're doing it. So where does this leave us? We cannot fully trust these safety evaluations. Previous models may be silently doing this already. But now we know we have to be a little more careful going forward. These tests are going to be exponentially harder. We can't just run a simple test suite and just trust the results, right? We have to account for the possibility the model knows that it's being tested and it's acting differently. So who knows what future models are going to do, right? These companies building these tests have to figure out in real time. It's not just we used to ask, can an AI perform this task correctly? Now we have to ask, will it perform it correctly when no one is watching? How do we do that? How do we have robust tests in the future? Well, still figuring out what exactly that means.